So hopefully you're here for the data wrangling with Python. I usually do this as a 3-hour tutorial. So we're going to see how it goes. I obviously am not going to be going through a lot of interactive back and forth, unfortunately, but I do have all of the notebooks that I normally cover in my 3-hour tutorial on this on GitHub. So it's all there if you want to step through. Today we're going to do a little bit about what is the data wrangling process, and then we're going to go into some data wrangling with 2016 US presidential election, because it's really fun to make fun of Trump, and I'm going to take a lot of pleasure in that. So here's my love-hate love story with data wrangling with Python. I'm Katharine Jarmul. Thanks for the nice intro. I like working with Python. I like working with data. And usually I like working with data in Python. I love teaching new Pythonistas, and I think it's a really important thing if you're good at something that you decide to go out there and try to teach, and even if you're not good at something, to try and go out and teach and have conversations about it. I think that helps our community. So the first thing is really, what is data wrangling, right? It means different things to different people. Sometimes I talk with people and they think data wrangling is just one specific part of the process. To me, it's kind of a larger view of the entire process, and that's what we're going to be talking about today. It is a struggle, right? Because how many people here are in academia? Okay. And how many people here work with data in like industry or in the world? Yeah, and especially those of us that work in industry and in the world, our data sets are really messy and they're awful, and we lose data all the time. Sometimes in academia you have that too. Sometimes in academia you have a focus on already cleaned or pre-processed data sets. So for me, data wrangling has kind of been a lot of that processing and a lot of that data munging. So even though I'm not an academic, and I don't plan to be, I really relate to some of the comics at PhD Comics. And I'll give you a moment to read this comment. And I found it, when I saw it, so relatable. I was laughing for quite some time, that you spend all of this time wrangling data, and you spend all of this time pre-processing it and trying to analyze trends and what are the outliers telling me and all of these things. And then at the end, you have one chart, and you're like, yeah, and either your boss or your client or your friend or your co-students are like, is that all you have? Like, what have you been doing? So if you can embrace this process, then you have a long career in data wrangling. If the idea of this frustrates you tremendously, then I would stay away. So formulating questions is a really important piece. And this doesn't just mean, okay, well, my boss told me or somebody told me that I need to answer this question, so this is what I'm going to go do. I think even if that's the case, or if that's the workflow that you currently have, it's important to try to formulate some of your own questions and try to continuously question even those questions and the assumptions behind those questions. So what are some tips? Do you know what's already been answered? So have you taken the time to go look, has somebody answered this question before? What did they find? Even if you'd like to do further analysis on it, it's really important to know what's already there, what's going on in the field, and what are your personal biases. So we all are going to have our own filters, our own personal biases, cognitive bias, whatever you want to call it. But we're bringing all of those with us, and it's a lot better if you just confront them and say, hey, this is how I view the world, and it's going to influence the way that I ask questions. What data sets are available? Obviously, you want to ask something that maybe you can answer. Sometimes this might mean collecting your own data, but other times this means really getting down there and looking through 1 million GitHub repos that are just marked down full of links and things like that. And listen to experts. So try to seek out experts. A lot of times, especially if they're academics or they're researchers, they're actually pretty interested in hearing from you and hearing that you're interested in using their data. So I highly recommend just reaching out and saying hi. So now that you have questions, or maybe you already have data, you need to potentially gather even more data. So even if you started with a data set, you wanted to ask some questions, when you went through that process, you found that you really realized you needed more data than you have. So what are some good tips? You really need to think about, where is the data coming from? Is the methodology listed somewhere? Did somebody already pre-process this and remove something? If so, can you talk to them? Can you say, hey, I really want to know, this looks like you did some pre-processing. Can you get access to the raw data set? Do you want to hear what they went through, all the stages that they went through, if they normalize the data? That's important for your research, right? Or for your analysis. And is the data in a useful format, or can you get it in a useful format? So if it's in beloved PDFs, then you might want to just write them or call them and say, hey, do you potentially have it in CSV form? And do you know all of the methods used in collection? Because if you're gonna defend your analysis, you need to understand the data that you start with. So cleaning data. This is a very unsexy topic, but as Big Data Borat says, it is what we do, right? You've probably seen this tweet or similar statistics. It's true, right? Majority of the time that you're working with data, you're spending time manipulating it, you're cleaning it, you're processing it, you're munging it, whatever it is. And for that reason, it's kind of this love-hate relationship, right? I gave a few talks. My most recent talk at PyCon UK, I gave a talk with how maybe machine learning is going to eventually change this for us, because we can start to become really meta and build machine learning systems that can process our data for us. So if you're interested in that, I have the talk on my website and it's on YouTube. So analyzing data, what is the data trying to tell you? What is it saying? What are you interested in? Again, back to your questions. And what is significant? So even if you're not a visual learner and you're much more of a numbers person, charts can help you see your data. And even if it's not for you, if it's for somebody else on your team, then it's a useful thing to use them, right? Because obviously if a trend is visually obvious, then the data is trying to tell you that, right? Pandas is what we're gonna mainly be covering today, but there's plenty of built-in statistical tools within a lot of the Python data libraries. You can look at covariance, correlation. Obviously, if you have a statistics background, then you have many, many ideas. But even if you don't have a maths or statistics background, it can be interesting to start and look at correlation between your data points. And using grouping can also show trends. So, and then at the end, right, you're going to need to share your findings. So you've consumed the data, you've been through the whole data wrangling process, you did the analysis, and now you need to share it with your team, with the C board, with your fellow students or professor. So an important thing is choosing how to share that. And one important stage of that is choosing your visualization. And this is an XKCD that was very funny to me, so I'll give you a moment. So obviously, this comic is about, understanding how to present your data. And some of understanding how to present your data is not just in what format, but it's also knowing your audience, right? So if you're going to choose charts, you need to determine, are these people that really understand data? Can I kind of show them a lot of the statistical methods I'm using? Or are these people that have very little understanding of data and I really need to step them through the process? So, that said, we're gonna actually do some data wrangling with pandas. I have the GitHub notebook posted. I'm gonna be working through it right now, and then it's there for you. It actually deals with FEC, election data. So we're gonna go right into it. And can everybody read the code at the back? Okay, cool. So I'm gonna import pandas at NumPy and CSV. This is just to get my data sets. There's a lot of notes in this, so I wouldn't worry about it, but if you want to look at them later, I'm telling you a little bit of my thoughts as I go through this. The first thing I'm going to do is I'm going to get my candidate headers. FEC data is going to be shared as header files and then the actual data files. And this is just, this is economic or financial data. So this is dealing with donations to US political candidates. And so I see that with just a simple list comprehension, I have my candidate header information. And what I'm going to do is I'm just going to use the pandas read CSV method, which is going to read it in from my CSV. I can pass in the names. That's going to be my column headers. And then I'm going to tell it what the separator is. And the separator here is the pipe character. Pandas gives me a really good view of it by just using head, which is just going to show me the first few rows of data. I usually use this when I'm working with new data sets so that I can see, make sure that the data looks relatively clean, and identify places where maybe there's problems. The next thing I can look at is a specific column. And as you can see here, Pandas uses simple dictionary syntax to access the columns. And these columns are not data frames, they're called series. So here is my first series, and I can see that it's just a massive column. One other useful thing when using Pandas is that you can create Boolean series and Boolean data frames. And this allows you to essentially put a filter on top of your data. So here, I have decided that I only want to focus on election year 2016. So I can put a filter and say, hey, show me only where the candidate election year column is 2016. And it returns this massive Boolean series. Oops, sorry. Well, I can't really do much with a Boolean series, but thankfully, Pandas gives me a way that I can pass that Boolean series to the data frame. And what it's going to do is it's going to say, okay, Katharine, here are all of the rows where that series evaluated to true. And I can use these. You can even use them with and or operators. With bin operators, they usually use the and or sign. And you can subslice your data. So what I'm going to do here is see that I can look and see that I can create a data frame from sub-selecting columns. So here I'm saying, okay, I care about 2016, and I only want the columns candidate ID and candidate name. And I can even create data frames that way. I can look at how many rows and columns I have by using the shape attribute, which returns a tuple for me. And that's going to tell me the number of rows I have and the number of columns. I can use lock to essentially act as slicing. So this is going to slice based on my index. And as you can see here, it will start at 6,940, and then go till the end. So you can use this lock to do some of the similar slicing that you're used to in terms of either NumPy or just normal arrays. I can also use iLock if I have an index that's, say, something like time series, right? And I don't want to sit there and pass time objects as slices. Then you can use iLock, and what it represents is index. So the I represents index, and then I can just pass a number that I know I have enough rows for that index. So that's another really useful way to sub-select your data. D-types are really, really important in Pandas. So everything in Pandas is built on top of NumPy types, and those are generally all Python types. So what that means is it's important to understand how Pandas is interpreting your data, because different methods and different attributes are going to be available depending on how it's stored, right? So here, when I see object, what that means is that's stored as a Python object. And when I see float, it's stored as a NumPy float. And there's going to be different methods available for me. One important thing to note is that if I start to see numeric columns, or columns that I expect to be numbers as objects, they're not going to have the numeric methods available. They're not going to be fast by any means, because you're iterating over Python objects, right? And that's suboptimal if you're doing large-scale evaluation. So it's really important to initially take a look at your D types. There's also a lot of really amazing ways to transform your D types of your columns in pandas. We're not going to go into a lot of them right now, but they're all there for you. But make sure you're looking at your D types because that's how pandas is seeing your data. So now on to the main show. How can we make fun of Donald Trump, right? So I thought, okay, how am I going to find Donald Trump's data? Well, it looks like the candidate name is last name, first name. So first I'm just going to try to subselect this. And this doesn't look very good. So if you've been using pandas for a while, then you know that this is an empty data frame. So that did not work. It returned no rows. Pandas is telling me, yeah, okay, here's some columns, but I don't have any matching rows for you. Okay, so why don't we take a look at where the candidate name string contains Trump. And I apologize now for the code of conduct violation that I am making in this. I apologize. It is not my data set. I can't remove things from it. And we see that there is a variety of Trumps in our data. And yeah, Salam, Mrs. Trump. So we've found Donald Trump now. We've also found some people. The US political system is very open in terms of nearly anybody can register and run for president. So there are some folks running for president also with Trump in their candidate name. Okay, so now I need to pull in the donations because I was curious about studying the donations based on the candidates and seeing, do some of the candidates have different types of donations? But to do that, I need to first pull in the donations data. And again, I'm going to look at the header first, and I have all of that, and I can import it in the same way. This is a little bit larger, so it's going to sit there and take a moment. And it's going to tell me a nice little warning that I have some mixed types. So this is, again, related to the D types. Now, this isn't an error. I have my data frame. But it is important to note these and start to think, okay, what's happening in my data that pandas is telling me, hey, I don't know whether this is an integer. We changed it to an object because it has mixed types. Okay, and so here's my data. And yeah, okay, it looks pretty clear. If I take a look at my D types, I can see, okay, I have quite a lot of objects, right, which is for better or for worse, but I see that these transaction amounts are integers, which is great because I'm going to be doing quite a lot of data on that. Pandas also has a really helpful built-in describe method, and what this is going to do is, again, this is something that's only available to numeric columns, and what it's going to do is it's going to perform some basic statistical math for us. It's going to tell us what is the standard deviation of each of those columns, what's the minimum, maximum, and then different quantiles, right? As well as counts. But this is really not very useful because you can see that we have numbers that are quite hard to read, but they shouldn't be that difficult because it's basically a way that describe is trying to be helpful to us, but it's not. So let's take a look at just the mean. So on any series, any numerical series, we can simply run mathematical operators. So we can run the mean, we can run the min, we can run the max, we can look at the median. And this is going to tell us different things about our data, right? And I thought, it was pretty interesting that somebody, the minimum amount was taking back $226,000. Like, no, I think I'm good. I'll just have that money back. Thanks. It could have just been an error too. I don't know the story behind that, but that might be an interesting story, right, to research. The other thing that I saw is this maximum donation is massive, right? That's 26 million. Okay, who gave 26 million? We'll get into that. So I'm going to load in matplotlib, which I can do with a simple pylab inline. This is just so we can start taking a look at some of the charts. And here I have a histogram, and what is this histogram telling me? Not very much, other than there's quite a lot of the data is in one area, the smaller donations, and then the rest are really, really so small that they're creating this histogram, which is skewed, right? Okay, so I want to try to link this data with the political contributions. And what I need to do with that is I need to try to join it on this candidate PCC. So these are these political action committees that candidates use to take in all of their money, right? So a lot of times I can't just go to a candidate and say, like, I'd like to give the money to you. I need to go to the candidate PCC and give the money to them. So one way of doing that is deciding to join based on the indices. So what it's going to do is here I'm setting my index as the committee ID, and I'm joining the candidates on this PCC. And this should work. But when I take a look, I actually have a lot of these nulls. So this is telling me that this join did not operate properly, right? It didn't join in the way that I expected it to. All right, well, then I can indicate to pandas, all right, I want to join right. And I want to make sure that first you have the donations, first you have the candidates information, and then link that to matching donations. And I also see that this is not working out very great for me. I don't want to analyze all of these nulls. I could maybe go through and figure out what's happening with that, or maybe go get more data and join them. But what I can also do is I can simply create an inner join. And this is just going to, similar to SQL, do an inner join for me. So this is looking a lot better, right? I'm not going to have those nulls. I'm not going to have mismatches. So I want to run that. Now I have it, and again, pandas is often, when you run these, they're going to return a new data frame or a new data type. They're not going to do it in place. There used to be very popular to run in place equals true on pandas and allow NumPy and pandas to make decisions about where to store that memory as it moves it all in place to the same pointer or to move the pointer. That is no longer the case, and it's definitely not the good way to do things. Do not use in place equal to true. Instead, set it equal to a new object. So you have a new object. Now my canned donations is going to hold the data frame with all of my information in it. I can again use describe if I'd like to take a look. And again, because the numbers are quite large, it's hard to show. I can show a histogram. And again, we see similar data. And again, I see that I still have my maximum value that I'm curious about. So I just said, okay, let's look at everything that's over 1 million. And I can look and see that here I don't have many rows. I have just 6 rows. I can use value counts, which essentially is going to just sum those for me. So what it's going to do is we see David Trone has 4 donations that are over $1 million. Bernie Sanders has 1, and Vincent Gonzalez has 1. The interesting thing, if we take a look at this, by the way, is that David Trone is the one who donated all of that to himself. So David Trone spent $4 million of his own dollars on an unsuccessful run for, I believe, Senate or House of Representatives. Good job, guy. All right. Then now I'm like, okay, well, who has the most transactions from small donors, right? Here I'm just going to classify small as under 200. I remember the median was 250, so we're going to go below that. And we see that by far, as reported in the press, Bernie Sanders had the most small donations out of all of the different folks who were running. I was surprised to find out that Ted Cruz was the second largest. That was news to me. And then we see Clinton is number 3. If I take a look at the columns, sorry, this is a bit messy. This is just to show you that they're always available to you as an array. So if you ever need to take a look and remind yourself of the columns, I often do this in my notebooks, So again, I want to subselect on just 2016. And now I want to group. And in pandas, this group by is going to allow me to pass either an array, and that array needs to have all of the column names, or I can just pass one column name. So I want to group by the candidate name, and this because I want to do some summation with all of the different transactions. So I can do this grouped sum, and this is going to sum over every single column that's numeric. And that's probably not exactly what I want, right? Like, I don't really care that the grouped sum of image numbers, that's not useful to me, right? So, okay, back to the drawing board. I can use Aggregate to instead choose which columns and choose which way I want to do it. So here I'm saying, okay, for the transaction amount, I want the sum and the mean. And for the name, this is the donor name column. I would like length of a set of X with lambda. Does anybody have any idea why I would care about that figure? Length of a set. So we know a set makes something unique or attempts to make something unique, right? And then I'm looking at the length. What might I be trying to calculate here? Any ideas? Number of unique donors. Yeah, so this doesn't take into account if we both have the same name and we donated. I didn't do very intelligent disambiguation here, but it will give us a ballpark range, right? So, and since we did the same statistical inaccuracy on all of them, everybody's on a level playing field here. So we can obviously create a more unique here, but for a first view, it's fine. All right, so I want to then add this to a new column. So I'm creating a new column, unique donors, and I'm gonna use the transform method. And the transform method takes a group by operation, and what it's going to do is it's going to map that to the same size of my initial data frame. So group by is not a data frame. It's a group by object, and it has different methods, and it has different things that you can or can't do with it. And it's also smaller, right? Because each of the groupings is going to have their own data frame. So you can't just take a group by and put it on your data frame. What pandas allows us to do is use this transform operator to say, hey, here's the math I care about in my group by. Now go add this aggregate to each of the rows in my initial data frame. And this is really great for performing things like this. Like, I want to know on each row how many unique donors that group had. So now if I take a look, I can look at the mean and the median. And now I say, okay, I just want the significant candidate donations. I want candidates that had more than the mean of the unique candidate donors. And when I take a look at how many that is, I can see it's quite a few. So when I take a look, however, if I group by candidate name, it is only 2 candidates. So only Hillary Clinton, which initially was her and now is her dual ticket, she and Bernie Sanders are the only ones that have a significant amount of donations. So what happened to Trump? Like, I was kind of just expecting Trump would be there, right? Because I just took a greater than the mean. I didn't take, outlier analysis. This is just like pretty standard analysis. Okay, so I need to take a look. And how many unique donors did Donald Trump have? I can do that by subselecting again where Donald Trump is and take a look at the unique donors column. And I see that Donald Trump only had 4,633 unique donors. This is compared to the mean, which is 71,000. So, good job, Donald Trump, again. All right, so because he is, I guess, technically running for president, I was curious. So again, this is gonna look at all of the counts of the rows. I was curious to add him back in. So I'm gonna add him back in. And by doing that, I can just simply use append. So to my data frame, I can always append, and that's going to add him back in. Really quickly, so we have time for questions, go through the transaction amounts, and we can see here that compared to the other presidential candidates, he has very few donations. And similarly, he has very few unique donors. So there is some homework or extra things that you can do with this data if you're interested. I'll really quickly switch back to this so we can get through just the very end. So what happens next? You're like, Katharine, that was great, but you wrote all that code for me. I hope that what happens next is, you can further analyze this data. I have links of how to get it all and to the data set again on my GitHub repo. If you have any questions, you can ask them now. I also must say that I'm helping organize the PyData Berlin conference this year. It will be the end of June. If you're interested in sponsoring, speaking, or attending, you can come see me. And thanks. Okay, so I do want to say that Jackie and I are giving out a free signed copy of our book. The second comment has the link. I don't know if this is easy for people to click on, but it's there, and it's also on the PyCon CZ retweeted the tweet. So if you want a free copy of our book, it's there. What about data that won't fit in RAM? Well, I gave a talk about Dask earlier today, so you should have been there. If your data can't fit into RAM, then of course you can't use pandas, right? Or you need to use pandas on a much larger CPU in the cloud. The choice is up to you. What I recommend is you actually take a look at a library called Dask, which I gave a talk at earlier today. And what it allows you to do is do parallelized memory and computation of pandas data frames. What's the link to the notebook? So the link to the notebook is going to be at my GitHub repository, KJam. It is in a series of notebooks called Data Wrangling PyCon. And if you go to books and other notebooks, then it's in there along with several other notebooks. If you want to look at the full data wrangling tutorial I give, then it is in just the books PyData examples. I've noticed CSV takes first row as header by default. Is there a way I can override it? So there's an ability to start at a different index. So if you need a different start at index, then you can simply pass the value of what index you'd like to start it at. And as you saw here, I didn't use actually the first row as header at all. I passed in a names argument, which was simply an array that allowed me to decide which columns are my own. Are there other questions? Because I think we probably still have a minute.
We have time for one more question from the audience. Would anybody want to ask a question? Raise your hand. So if you're too shy, you can talk to Katharine afterwards. Thank you for the talk.
Thanks again.